Welcome back to elementary statistics. In this video, we're going to go through some other methods of central tendency. We've already looked at the mean, the classic meaning of average that you've seen throughout your academic careers. In this video, I have a couple of other tools, some of which you may be familiar with, some of which you won't be. But before I even get into those, I want to mention a couple of tools for average that we are not going to talk about in this course that you may come across in some future course, either in mathematics or in the applied mathematical sciences. Namely, I want to mention the geometric mean, which is useful for thinking about extending the idea of mean into two-dimensional objects. And then the root mean square, where you take your scores, you square them, then you take the mean, then you take the square root, is something we're going to build on for another concept in this course. But that's a tool that's useful when you are dealing with a distribution that can contain negative values, and especially if anyone is going into physics and engineering, where you can contain imaginary values. Those kinds of distributions are not going to come up in this course. We're not going to spend any time on them, but I like mentioning that there are more options than just what we're going to cover. All right, let me get my head out of the way and let's go into one of the ones that we are going to talk about, namely the median. To explain the median, we first are going to need a distribution, and I'm going to present this distribution as raw scores. It doesn't matter what the scores in the distribution are. The only thing that's really important is that we're going to have a grid that's going to be 5 numbers across and 6 rows of these 5 numbers. Let's make sure that this last one in the third row is 29. The first one in the fourth row is 31. And again, the rest of the numbers don't matter, except that they are arranged in increasing order. All right. So we have our distribution. It has an assortment of scores. Specifically, I chose to construct a distribution that has 30 scores in it. And I've arranged these scores from smallest to largest. That's the important thing. If you're copying these down and you don't have the exact same numbers, again, that doesn't really matter. The idea of the median is to divide the distribution in half. This particular distribution had 30 scores in it, so I want to divide it in half so that the fifteen lowest scores are in one group and the 15 highest scores are in the other group. And the question we ask is, where does the dividing line fall? If we're lucky, there is a score that's exactly in the middle. In that case, that score is the median. More often, we are not so lucky, and the score is going to be somewhere between these two values. Right, so our median is halfway between 29 and 31. Well, we've figured out halfway between numbers before. Add those numbers together, divide by 2. In this case, we get 30. And that is our median. Our book uses the symbol MD for median. I tend to write out the entire word whenever I'm talking about it because the symbol for median is actually not standard. I've seen capital M, I've seen X sub M, I've seen M sub X, I've seen MD, um, because there's no one way of talking about the median. I like to just write it out in order to make things work out a little bit more quickly. All right. So that's all well and good. If we have our data listed out in a complete set like this, we can figure out the median. But as we've seen throughout our course, more often we have not raw data like that, but a frequency distribution. A frequency distribution is great because it allows us to consolidate a lot of information in a small space. So let's take a look at this frequency distribution. I'm listing out my midpoints. I'm not giving the class range because it's not something we need, so it's saving us a little bit of effort. But I have scores of 1, 2, 3, 4, 5, 6, 7, and 8 with corresponding frequencies of 3, 5, 7, 8, 11, 18, 12, and 9. If you sketched out the corresponding histogram, you would see that this is a distribution that is skewed left. It has some low outliers, and the peak is going to be off to the right somewhere. When it comes to trying to work with the median, a frequency table is not actually the best tool for the job. It turns out that it's a lot easier to describe the median when you have a cumulative frequency table. And so we start. The first group has 3 entries in it. There are 5 more. 5 plus 3 is 8. The next group gives us 7 more. 8 plus 7 is 15. And then we have 23, 34, 52, 64, and 73. So we are looking at a distribution with 73 scores in it. And from here, I want to think about the same process we used before. We want to take our distribution and cut it in half so that the lowest half is in one group, the highest half is in the other. Well, we don't want to have to write out all 73 scores, but we can still think about that same picture. If I take 73 and I divide by 2, I get 36.5. All right. If this had come out to an even number, then we would have the same picture we had before. If I had done this division and I'd gotten exactly 35, then that would tell me I'm looking at the lowest 35, the highest 35, and the median is the boundary between them. Because it came out as a fractional value, you'll never have a fractional value other than 0.5. But because it came out as a fractional value, that means that in this case, I have the lowest 36, then I'm going to have the median, and then I'm going to have the highest 36. And the cumulative frequency distribution will tell us exactly how to deal with that. The highest number on the cumulative frequency chart before we get to 36 is 34. So scores of 1, 2, 3, 4, and 5 give us the lowest 34 scores. That means that the 35th score is 6, The 36th score is 6. 37th score is 6. And that continues down till we get to the 52nd score, which is still 6. The lowest 36 scores get grouped together. The highest 36 scores get grouped together. And the one in the middle is the median. So the median of this distribution is 6. Ideally, we don't have to write all of that detail out as we are looking at the cumulative frequency. We see that 34 is smaller than the place where the median is going to appear. We see that 54 is bigger than the place where the median is going to appear. Well, every score from the 35th score to the 52nd score is all in the same class. So just figure out what the midpoint of that class is, and that class gives you the median. Thinking about the median tends to be a little bit esoteric until you get used to it, but you will get used to it, and then things will make a lot of sense. Let me go ahead and, whoops, I didn't mean to cut. Let's put that back. And now I have it in the clipboard, so I can scroll down and paste. Let's look at the same frequency distribution again. To get to the next object of central tendency, which is called the mode. The mode is the most frequently occurring score. So when you have your data in a frequency distribution, finding the mode is very simple. You look at the column of frequency, you find the biggest number in that column, and you grab it. Right? The biggest frequency is 18. The score that has that frequency is the mode. When we first started talking about frequency tables, I talked a little bit about paying attention to which numbers mean what things. The column that I'm labeling as X are the scores in the distribution. Those are the individual data values. The column that I'm labeling as F is the frequency of that score. It tells you how many times that particular score appears in the distribution. The median and the mode are talking about things that are happening to data values. So the mode is asking which data value has the highest frequency. We look at the chart, we find the frequency that is the highest, and then we take that and look at the corresponding score. That step of look at the corresponding score is important. If you're not doing that, then you're going to report the wrong thing. I cannot tell you how many times I have asked a student to find the mode of a distribution like this, and they report 18 because they're in a hurry, they're not paying enough attention, they grab the wrong number. So pay attention, be careful, don't make that mistake. When we were talking about the shape of a distribution, one of the shapes I talked about was called bimodal. And it is possible for a distribution to have two modes. Technically speaking, you're looking at the case of there are two different data values that both have the same frequency, is the formal definition of a bimodal distribution. In practice, going and looking at the picture is where I want you to take that. If you suspect that a distribution has two modes, And it's not that difficult to come up with a distribution that is going to have two modes. Let's take the same scores. 1, 2, 3, 4, 5, 6, 7, and 8 is pretty easy to work with. Here we have uh, those 1 through 8 with frequencies 10, 15, 18, 12, 7, 15, 21, 14. Using our definition of the mode in this distribution is 7. But one of the things that draws my attention is that we're smaller, we get bigger, we get smaller, and then we get bigger again. And so if I draw out the histogram for this data, I can see pretty nicely that bimodal curve appearing here. So there is the case for saying that there is one mode in this distribution and that mode is 7. There is the case for saying that this is bimodal. With modes at 3 and 7. I try to stay away from these kinds of trick questions. Tell me the mode and not tell you that it's bimodal. But I do want you to be able to look at this and understand why this is a bimodal distribution. The one mode happens slightly more frequently than the other. Um, so generally, if I'm just saying find the mode, recognizing that there's a single mode here is all we're going to do. Um, but I like to have you think about those sorts of ideas as well. um, when you have a set of data that has more than two peaks, we can call it multimodal if you want to. But generally, at that point, you're getting away from there's actually peaks in this data and you're going more towards the data is noisy. It's really a flat distribution with a lot going on. So one mode is common, two modes is actually incredibly common. More modes than that, it's not worth calling them modes anymore. I've got one other measure of central tendency that I want to talk about, and it's called the mid-range. Right. To talk about the mid-range, we have to talk about a little bit of vocabulary, some of which is fairly common sense, most of which we have actually already talked about. That is the maximum, the minimum, and the range of a distribution. The maximum of a distribution is the highest or largest individual data value in the distribution. The minimum of a distribution is the lowest individual. data value in the distribution. And the range of a distribution is simply calculated as the maximum minus the minimum. The mid-range of a distribution is a little bit odd to think about at first, but it should make sense pretty quickly. The mid-range is calculated as the maximum plus the minimum divided by 2. And that's a structure we've used a couple of times already. When we're calculating max plus, or add two things together, divide by 2, that's the calculation we use to find the number halfway between those two numbers. So if you think about a distribution and you think about the histogram for the distribution, the range on the x value, right? The range is talking about where the x values of the distribution are. And your maximum and your minimum are the endpoints on the x-axis. The mid-range is asking you to name the point directly in the middle of that distribution. So thinking about that in terms of symmetry is going to be a very useful tool. So let's see, I think I still have a distribution in my clipboard. Let's just paste that in. Come on. There we go. Just paste this distribution in. We can draw a histogram for it relatively quickly. All right, so I set up my vertical scale counting by 3s in this time. Doesn't really matter, just need something. All right, so that's just a real quick histogram of a distribution we've already looked at once before. In this case, we can calculate the maximum. It is the highest score in the distribution. In this case, that's 8. We can find the minimum. It is the lowest score in this distribution. In this case, it's 1. And the range of the distribution is 8 minus 1, which is 7. The mid-range of this distribution, we calculate by taking 8 plus 1 and dividing by 2. 8 plus 1 is 9. 9 divided by 2 is 4.5. And 4.5 is right here on the distribution. So if you look at this, you look at the maximum, the minimum, and the mid-range, it becomes very clear very quickly that on the x-axis, the mid-range divides the data set in 2. There are as many scores to the left of the mid-range as there are to the right of the mid-range. But that's not talking about the number of scores. That's talking about the different scores, right? 1, 2, 3, and 4, 5, 6, 7, and 8. Looking at the histogram, what we see is that there are a lot more scores up here on the higher side of the mid-range. There are a lot fewer scores over here on the lower side of the mid-range. It's one more piece of evidence that this is a skewed distribution. It is clustered on the high side. It has low outliers, this distribution is skewed to the left. All right, so that's one purpose that the mid-range will serve. Um, the mean, the median, the mode, the mid-range. I talked a little bit when we were talking about the skew of a distribution. The mean is the most valuable when you have a symmetric looking distribution. And honestly, when you have a symmetric looking distribution, the mean, the median, and the mode and the mid-range are all about the same value. When you have a skewed distribution, the median becomes more useful, the mid-range becomes more useful. When you have a bimodal distribution, the mode definitely becomes the most useful there. Um, let me draw a quick picture of a skewed distribution. All right, we had a skewed left distribution there. Let's look at a skewed right distribution this time. And when you look at this distribution, you can very quickly point out where the mode is. It's the peak of the curve. It's actually not too bad to figure out the mid-range. Just look across the x-axis and cut it in half. The other two are less obvious. But the median is going to be closer to the mode, and the mean is going to be closer to the mid-range. And in fact, in some distributions, if you have enough skew, the mean will actually slide to the other side of the mid-range even. And if we had data that was skewed with low outliers instead, the whole picture would be flipped around. But that picture, I think, gives a good sense of how these scores will relate to each other in various different kinds of distributions. Knowing that can help you describe the skew of a distribution. I had mentioned before there's a calculation. The calculation for skew of a distribution actually involves the mean, the median, and the mode. Again, I'm not worried about performing that calculation in this course. Just being able to recognize skew from a picture is good enough for me. When we were talking about the shape of a distribution, I gave you one example of a bimodal distribution that has caused confusion in history because the wrong choice of average was used. I'd like you to let me know if you can think of anything else. So for discussion, can you think of a real-world distribution where the skew of the distribution, or generally the shape of the distribution, would make the mode, the mid-range, or the median a more valid or a more reliable description of the average of the distribution than the mean? What is it about that distribution that makes that the case? You may have even come across this reported directly. There are some things that often show up in popular media where they talk about the median or where they talk about the most frequent, which is the mode. Um, I'll be honest, I've never seen a place where the mid-range is the most reliable choice, but it technically could happen, so I'll include that on the list. If you can find something where that does, I will be very interested to hear that. Yeah, that's all I have on this video. So think about that if you have some time. If you have anything interesting. Thank you as always for joining me. I'll see you next time.